So our student asked me about this question. It's if 81x squared is a term in the expansion of 1 plus c all cubed, find c. So this is a binomial expansion problem. Right, so we've got 1 plus cx is a binomial taken to a power. Right, it's probably a complex, unfamiliar problem, right, because we're going to do some slightly different things. Alright, so have a go at the problem if you haven't already, and then follow along. First thing you want to do is write out the general term. So for a plus b to the power of n, the general term is n choose r, a to the power of n minus r, b to the power of r. Right, so for our expansion, 1 plus cx all cubed, we're going to replace a with 1, b with c times x, and n with 3. So a general term is going to be 3 choose r, 1 to the power of 3 minus r, right, times cx, and the whole of c times x, not just x, to the power of r. Now obviously 1 to any power is just 1, so that's a bit sort of boring and pointless. All right, so let's just simplify that a little bit. 3 choose r. All right, c gets the power of r, x gets the power of r. All right, and we want to set that equal to the term we're given, so we can work out which term we're looking at in the 81x squared. So we do that. Now, the powers of x have to be identical for this to be true. So r must be 2. All right, if we've got x to the power of r equals x squared with some coefficients, the coefficients have to be the same, which we'll get to, and the powers of x have to be the same. So we know that r is 2. So we're looking at r equals 2 terms. So let's write that out again one more time. 3 choose 2, c squared x squared equals 81x squared. And cancel these x squareds, we don't need them anymore. We get 3 choose 2, c squared equals 81. Let's just work out what 3 choose 2 is. If you can't do that in your head, use Pascal's triangle. So 0, 1, 2, 3 rows, then we go across the 0, 1, 2, 3 column, and we get 3 choose 2 is 3. So we get 3 times c squared equals 81. Let's divide both sides by 3. We get c squared equals 27, so c, we have a square root of 27. Which we can play with a little bit, and we get that that's 3 to the power of 3 halves, or 3 root 3, if you like. I didn't write that bit down. So the key thing with problems like this is we take our general term and we start equating powers, and we end up with an answer. Thank you.